Hi folks, welcome to Unit 4, Lesson 4, and the remaining videos are going to deal with the examples on the worksheet, but I just want to give you a little introduction on some of the ways in which we apply calculus to economics, or at least give you a sense of some of the terminology that's used. All right, so I want to actually start by reviewing some of the questions we've already seen where we have these applications to economics. So if you look at lesson 2, we had the question about producing the salt container, and the idea here was to minimize the amount of material used in order to produce a given volume for a container. Okay, so certainly a very important and common type of problem that one might encounter. All right, then we saw something similar in the next lesson, where again you were building another container, in this case here rectangular prism jewelry box, but here we were looking specifically at the cost to produce it, and the issue here was that different parts of the box cost different amounts to produce. Okay, but again a very similar setup to solve this problem here. Number 4, which we would have looked at, another interesting problem, this idea of again building this set of cables to connect to points that are divided by both land and water. Okay, and again, it's a geometry problem that involves trying to minimize the cost. All right, and in fact, in today's lesson, we have another similar type of example where we're trying to maximize the printed area on a poster. All right, so again, maybe you're trying to design some sort of advertisement and you want to maximize. So we notice all these things are very geometric in nature, and that is one type of problem for which calculus can be used in applications to economics. But another one has to do with this idea of revenue, cost, and problem. Okay, so the first problem that you'll see is one that should actually look very familiar, because you would have solved these types of problems back in grade 11. And the idea here is that every time you increase or decrease the price of a particular product, in this case you're an ice cream cone, you'll sell more or less cones. All right, and I just want to give you a heads up, because I'm going to solve this a little differently from the way you solved it last year. Last year, the variable that you used was the number of price increases or price decreases. So hopefully that sounds familiar, and you certainly can solve this problem in that way. Okay, but I'm actually going to solve a little differently, because if you look at the cost function, okay, and we'll talk about this in a second, you look, the cost function is not given in terms of price increases or price decreases. It's given in terms of the number of cones that are being produced and sold. All right, and this is the more natural variable to talk about revenue, cost, and profit. Okay, number of increases or decreases is not a particular natural variable to use, and it's not the one which is normally used to define these three functions, which we're going to talk about in a second. Okay, so while you certainly can solve this problem in your grade 11 method, okay, be very careful about how you're using this cost function. I'll give you that heads up. But if you watch the video, you'll see that I actually take a different approach. Okay, one that allows us to work with this particular variable. All right, so why do I want to work with the number of items that we're working with? Because as we see here, that is the typical input variable that we use for all of these functions. All right, so let's take a look at these functions, and most of them have very very obvious definitions here. So here we have the cost function, and again I'm going to think of the cost function in terms of x, where x is the number of units. Okay, so here the cost function will be given in terms of the number of units that you're producing, which makes sense, that as you're producing more units, the cost you expect to go up. However, it might not necessarily go up in a linear fashion. Okay, so for example, at a certain point, if you make more than 100 units, will you have to buy a new machine, which will create a big increase in the cost as you move from, say, 100 units to 101 units. Okay, so we can't assume that this cost function is going to be a linear function. All right, so next we have the price function, but the more official term for this function is the demand function, and that's the price of a product being sold. Now, again, you might sort of think, well, the price of a product is a price of a product. Well, no, very often the price that gets charged depends on the demand for the product, depends on how many items you're going to be selling. That if you're going to be selling lots of items, that it could work both ways. You could sell a lot of items because, the price is low. Okay, or if a lot of people want your product and are willing to pay more, you might charge more. So again, the price which gets charged can also be dependent on how many units are being sold. All right, then you've got the revenue function. So revenue function, again, not too surprising, is what you take in for selling a particular number of items. All right, now we're going to assume in our scenarios that the only way that you're taking in revenue is to sell your product. Okay, so if you're selling X units and each unit costs P dollars for that number of units, then the revenue function is just given as X times lowercase p of X. All right. Now, obviously, if this price is constant, meaning the price does not depend on the number of units being sold, then this would just end up being a linear function. But we can't assume that it'll necessarily be a linear function, like we can't assume that the cost would be. All right, and then finally we have the profit. So how much money do you make after you've paid off all your costs? And this profit function is just a combination of revenue and cost. It's just the revenue function minus the cost function. So how much money have you brought in, subtracted by the amount of money that you've paid out to produce those items. All right, so this is what you'll be using to solve that first question in the worksheet. All right, so again, more often than not, this is the input variable that's being used as the number of units and not something like the number of price increases. Okay, so I'd like you to consider using this method to solve these problems. All right, so these are the functions themselves. But then there's other functions that we're going to look at. Okay, and we're going to look at what's called, and I'm not going to show you the definition right away, is we're going to look at what's called the marginal cost. Okay, so marginal cost. Okay, and then you've got the marginal revenue. And then you have the marginal profit. Okay, so what's up with this word marginal? Okay, so what the marginal cost, revenue, and profit, well, they all have something in common. Okay, and let's say I use cost as my example, and it's the exact same thing for all three of them. Well, the marginal cost is, say I sell 100 units. Okay, it costs me a certain amount. The marginal cost is given by, so the marginal cost is the increase in cost to produce the 101st unit. Okay, so how much does it cost me to produce one more unit? Now notice how I'm starting with a particular number of units, because if I'm selling 500 units, the amount it costs to produce one more unit might not be the same. All right, so if you think of this on a graph, and similarly for these others, what is the marginal revenue? It's the revenue that I make by producing by selling one more unit of whatever I'm selling. Okay, what is the marginal profit? It's the profit that I'm making, or possibly the amount of money I'm losing by selling one more unit. So let's take a look at what that would look like on a graph. Okay, now the other thing you have to remember is that my variable X is the number of units that are being produced and sold. So this is going to be a discrete function, meaning this can only take on integer values. Okay, so if I have, say, 100 units, so let's say I'm looking at cost here. dependent on the number of units that are being produced. So this is my cost to produce 100 units, and then this is my cost to produce 101 units. Okay, so as my X value goes up by 1, what does my Y value go up by? This is my marginal cost. Okay, but then you realize, well, wait a minute. If this is a linear function, this would just represent the slope, the amount that the Y goes up as X goes up by 1. Okay, so again, if this was linear, it would just be the slope of the line. But of course, very often, these are not linear functions. So say this is my cost function, okay, and you realize, well, wait a minute. If I'm talking about from this point here, how much it costs me to produce one more unit, you realize that this is still representing the slope of a line, just not the actual cost function. It's representing the slope of the tangent to the cost function. Okay, so this is why we realize that marginal cost is just the derivative of the cost with respect to X, and the marginal revenue is just the derivative of revenue with respect to X, and marginal profit is just the derivative of profit with respect to X. Now, depending what type of economics course you'd be taking, you might not actually ever be bringing in this idea of derivatives, okay? But given that we have access to calculus, we realize that what the marginal cost, revenue, and profit represent is just the derivative of that function with respect to the number of items being produced. So that's why, we have the more common definition, okay? So the increase or decrease in cost, revenue, or profit when the number of units increases by 1, okay? But we realize, based on our diagram here, that that's equivalent to the derivative of the cost, revenue, or profit at that particular point. All right? So one of the questions in the homework deals with the relationship between marginal cost and marginal profit. In fact, leads to one of the most famous formulas, I suppose, in economics. Okay, so that's a video that I'll be posting. It's page 154, number 16. So make sure you take a look at that one. It's actually a pretty straightforward question, but when I take it up, I'll talk a little bit more about what it means. All right, so the last thing that might come up in the homework, okay, is this idea of average cost. Okay, so in other words, on average, how much does it cost me to make a particular object? Okay, so let's say I'm again making 100 units. Okay, and the cost for this 100 units is $5,000. Well, what's the average cost? Well, it makes sense that I just take my $5,000 and divide it by the 100 units that I've made. Okay, so on average, it costs me $50 per unit. Okay, now does that mean that the first unit, if I only made one unit, it would cost me $50, and that if I made 2 units, it would cost me $100? No, not necessarily. Okay, in fact, when you think about it, it doesn't make sense. You have to spend a bunch of money to even start making. You might have to buy a machine. So if the machine costs you $1,000 to buy the machine, and you make only 1 unit, well, hey, it's going to cost you $1,000 to make that 1 unit. So this is average cost. So when you look at the way it's given, cost is a function of the number of units being produced. So whatever the cost is for that number of units, I divide by that number of units. So this is something that should come up in the homework, and this is the formula that represents this idea of average cost. So once you figure out what the total cost is, you want to know, on average, how much did it cost to make that number of units. All right, so go to number 1, go to this question here, and see how I give an alternate view on how to solve these types of problems. And eventually you'll get to that question involving marginal cost and marginal revenue. Okay, that's it for now.